Hey friends, welcome to a new lesson based on PostgreSQL database, and we get to see how to integrate this database in our dartfrog application. PostgreSQL also referred to as Postgres is a very powerful open source relational database, and it's known for its robust features and compliance with SQL standards. It's widely used in various industries and applications, as well as platforms like Serverpod, which is for data developers, and I'll leave the link to that tutorial in the description box below. Now let's proceed. First, we need to install PostgreSQL, but you can also do this using Docker. Docker is a containerization platform that allows you to just run applications in isolated environments with ease. To have a quick understanding on this, I will leave a link by Fireship. He explains it very well. Next, we're going to let me show you how Docker looks like. It looks like this. So it will this is where we're going to actually install our PostgreSQL, and it's going to display. You'll be able to have a container specifically for Postgres database, and to be able to do this, I'll leave a link down below on how to install PostgreSQL in Docker. It's pretty simple, and once we're done, we'll be able to proceed to the next. So you can pause this video for a minute and install those two platforms. Now that we are back, we can proceed to, once you're done with that process of installing, you'll have a container in your Docker. And now that we have that, we can proceed to our terminal and access our PostgreSQL database and create a database based on our application. To do that, let's access PostgreSQL by running docker exec. Make sure that this container is a container that you've created, and then you enter your username. Let's click enter, and it will direct us to the PSQL command line interface. Inside here, let's create our database. So we'll just run create database my task lists and enter semicolon. Let's enter this. So our database has been created. To be able to view the list, we'll just pass in the backslash and enter list, and we'll get to see our database has been created. Now let's proceed to, there's another platform that I'd really like to show you, and this platform is called Postico. Postico helps us to access or to communicate and access PostgreSQL in form of UI base. You're able to view your database, see the data that you have and all that. So we can install it, and once you have installed it, it looks something like this. This is how it looks. So we need to enter our database and then proceed to enter our username and password. It refers to the one that you created or provided when you are creating a container inside Docker. So let's try that. So my database is called my task lists, and then we'll just have PostgreSQL and my password. Let's test that. Great. Now let's connect, and here we are. So we don't have any tables. These are just default tables that come in. So what we're going to do, we're going to create our own table that will handle the list entity. And to do that, we just enter create table. So this is SQL language, and we'll name our table list that will handle the list entity. And inside here, we're going to proceed to define our fields. Our first field will be an ID, and we want it to be unique and act as the primary key. Next, we have the name, which will define it as varchar or equivalent to text with 100 characters, and it should not be null. Now let's execute this statement. Done. If we refresh this, we'll get to see our list, and here we are. We have set up our PostgreSQL. Now let's go and perform the fun stuff, which is now coding. Back to our application, we have the roots folder. We'll be working on our PostgreSQL inside the DB folder. So let's open our terminal, and inside here we're going to start by defining the middleware. So we'll just say dartfrog new middleware, and instead of MongoDB, now we're going to enter PostgreSQL. Great. So we come here and we have our PostgreSQL folder created and our middleware. Let's work on our middleware first. So we'll delete all this. As usual, you understand by now what this is all about. So we'll create a return, pass in the context, and enter async. Then we're going to create the connection for our PostgreSQL. So we'll just define a variable called connection. And before that, we need to install a specific Dart package called PostgreSQL. Let's just run dart pub add postgres. Great, we have that running. Now let's proceed to define it. We'll define our PostgreSQL connection. And inside here, we're going to define the host. Currently, my host is localhost. And then define the port, which by default it's 5432. Then define the name of my database, which is my task lists. Great. Then inside here you can also specify the username, set to Postgres, and also specify the password, which I'll set as dartfrog PSQL. Now there is our connection. Next thing we'll do now is open the connection. So we'll just say await connection.open. And then we'll proceed to send the request to the root handler, the respective root handler, which we haven't created yet. We'll create it. So let's just minimize this. So we'll have final response is equals to await handler. And then we're going to use the use method so that we can use a provider, which will allow us to inject the instance of our connection. So we'll just say provider of type PostgreSQL connection, and then we'll pass the connection that we have created. Great. Next thing we'll do now is, before we return the response, let's make sure that we are closing our connection, and then now return our response. And there we have it. We have created our connection to PostgreSQL and handled our return and our response. Now let's create our root. So inside here, we're going to proceed and say dartfrog new root PostgreSQL, and enter. So it will create for us an index.dart. Great. As usual, our index.dart in this application, in this tutorial, will focus on create and read. So we'll have a get and a post. So let's clear this up. So let's define our switch, pass in the type of method, request.method, and inside here we'll handle the first case as http method.get and pass in a function which will call getLists. Pass in the request context as a parameter, then pass this to our case and pass the context as a parameter. Next we'll have .post, which let's define the function that will pass there, and we'll call it create list. We'll copy this and pass it and pass the parameter. And lastly, let's set this response to future, pass in async, and then lastly let's handle the default case, which will be future.value, and define the response. Set the status code as http status.method not allowed, and we'll import a library that will handle that. Great. Now let's work on our get lists. In our get list, we'll define a variable that will be of type, will be a list that will hold map objects that have the key as string and the value as dynamic. Next, we're going to get the PostgreSQL connection. By doing that, we have our sync. We'll just say context. This is how you get the injection. Request, read, then specify the PostgreSQL connection. Then we call the method query. And this is where we add our query, which will be select list ID, because we have ID and name, so we select ID and name from lists, simply as that. So whatever we get, we want to assign it to a variable called results. And once we have that, now we want to loop through and pass the results that we get into our lists, so that it comes, we return it to the app in form of somewhat of a JSON object, or or JSON object inside an array or inside a list. And if you're not familiar with SQL language, I will leave a link in the description box below on where you can have some basics on it. But this is the query. This is an SQL statement that selects specific fields that you specify from a table. Okay, so let's do a for loop. So we'll say for final. We're picking every row that comes in our results, or every record that comes in, and then we're going to add it by, so we're designing a JSON object for ourselves. So we'll set the ID to row comes as the first index, and then we'll set the name, which will be the second index, which we define as 1. I hope it makes sense. Now that we have done that, it will be much more readable to the application when you receive this. So we'll just say return response.json body lists to string. And there we have it. That's as simple as it gets. Now next, let's create our list. Oops. So in our list, we need to get whatever is passed in the body. So that will be context.request.json and cast it as a map string dynamic. Then we'll pick the name because that's what we're actually updating by passing in the key name and casting it as a string. Now the next thing we're going to do is call our PostgreSQL connection instance by reading it from context PostgreSQL connection, and then we're going to call the method query. And to be able to create, we use the insert statement. So we're just going to say insert into the lists table, define the name, the field that you want to insert, and then we do call values and specify what value we want to pass to the name field. That's what it is. So let's do that. Pass in the name. So the reason why we're getting this error, first let me finish by the reason why we're getting this error is because we are considering that there's a possibility that the name might not be passed. Of course, in the application side, the mobile app will have to make sure if you're trying to update, you must at least add something. But we can do a check if name is not equal to null. So the error has gone. And this is just because things are in double quotes. But this is how the statement goes. Insert into this table this field and give it the value, this variable that we have. That's basically what it's doing. And I know that there are other ways of doing this. You can use ORMs, but in this case, we're just trying to appreciate just doing a basic PostgreSQL, interacting it with some of the SQL statements. But you can also use ORM to, there's a package called ORM that you can use to do that. I haven't interacted with it yet. Now that we have that, we want to pass whatever is returned to a variable called result. And now that we have that, let's proceed to define. We'll say that if result dot affected row is equals to 1, that means there's a row that has been changed. We'll return a response dot json and specify the body, and we'll specify the body by just saying success true, else we'll set it to false. That means nothing has been changed after passing this. Nothing has been changed to the table. So affected means either there has been a modification or there has been an insertion of data into the table. Now that we have that, let's implement a try and catch just for error handling. So we'll have that, and then we'll have that, and then we do a catch. And inside here, we'll just call return response and just specify the status code. HTTP status, the connection closed without response. Let's see if we have that connection in place. Yep, connection closed without response. We can give that error. Then we have the if here, so let's pass an else. I will just say return response and pass in the status code bad request, because you need to pass a name if you're calling this specific function of pushing a post request to this route. So yeah, basically we're done, and as usual, after creating our C and our R operation, we'll head over to our terminal and test these two. So to exit from here, we can enter exit, and then we'll just clear the terminal. Let's clear the terminal. Let's run our curl. Our first curl will be a get. Instead of db mongodb, we'll say PostgreSQL. Great. And we have received an empty list. So let's try and do a post. Post. And now let's update our, say, curl request post. Let's update our root to PostgreSQL. PostgreSQL. And then we have our name, which is shopping, and we already specified in our database, basically our table, that it's a primary key. It should be auto incremented. That's where the keyword serial came in when we were creating our table. So let's enter this and see. So we have an error. Let's see what's up. Future dynamic is not a subtype of type. So we've definitely forgotten to add an await. Yep. Now let's run this again. Success true. That was quite fast if you compare it with MongoDB, but because we were using MongoDB, we're using a cloud platform, but PostgreSQL it's in our local machine. So if you now that since it's successful, let's do a get and see. There we have it. And another way to check is also using Postico. So on Postico, we can just refresh and see. As you can see, there is our first list added, which is awesome. So our C and our R operations are working. Let's now work on our update and delete. Just a quick one, friends. If you're passionate about mobile app development or just getting started, please subscribe to MOBETERST Studio and join our community of app enthusiasts. It does mean a lot. And if you like my free content and tutorials, you can also support me with coffee. Thank you. So to do that, we just go back to our terminal. Let's pick one of these guys and just run dartfrog new root and specify a dynamic root. Click enter. Once it's created, we'll have it. Oh wow, that was a mistake on my part. Let's just delete this, move to trash and go back. missed out on a slash forward, click enter, and inside we have our dynamic route. Now let's work on this. We'll clear everything here and run return, use our switch, pass it the context.request.method, and inside here our first case will be http.method.patch, and pass in the function future response update list, pass in request context and the string. Let's copy this function and pass it here and pass the parameters context and id. Next we have the http method.delete. Let's define a function for it. Delete list. Copy this and pass it the context and the id. And lastly, let's update our response to future and add in a sync. Then we just define our default case, hold future.value, define our response by passing in the status code http status.method not allowed, where we'll get it in the library.io. Let's close our semicolon. Now let's work on our update list. So for update list, we need to get what is passed in our body. So we'll pass in an await. So we just need to set a sync here. Context.request.json and cast it as a map string dynamic. Then we'll pick the name that's passed in the body. We're just saying body and specifying the key as name as string. Next we're going to check if name is not equal to null. We'll perform a function here. So we'll just call get the injection, the PostgreSQL connection instance context.read PostgreSQL connection, and then just run the query. So what we're doing is we're going to enter an update statement to write an update SQL statement. Just write update, specify the table which is lists, and then we want to set the name field is equals to, then we just pass the name like so. And we need to explain where. So we'll just say plus where id is equals to id. That's in our in our function arguments. And then we close it. So let's see where we have. So if we save this, so if name is not, so it seems it will always have a value, but no. Let's just say if name is not equal to null. So this is the statement that we'll have. So we're just saying await and just running the update statement. So we want it to update the name to whichever name that has been passed in our body, where the ID is equivalent to the ID that has been passed here. Great. Now let's just, there's a result that will come in. Let's assign it to this variable is equals. Good. So let's just do the usual, like in the create list, where we say if result dot affected row is equals to 1, we just return a response dot JSON and specify our body that says success true, else we'll specify the success to false, and then we're going to add a try and catch, try, and then add a catch here, and if it falls in on the catch block, we'll just run a response dot specify the status code to connection close without response, and then under inside here we have our if. So let's handle our else, and we'll have we'll just specify it as a bad request, and we're done. Ignore this. The lint is expecting us to set these quotes into single quotes, but as you can see, there are certain single quotes we need to pass for the sake of the statement to run, for the query statement to run. But as other than that, we are done with the function. Now let's work on our delete. So in our delete, we'll have, let's get the instance of our PostgreSQL connection. And then call the query method. And what we're going to pass here is delete from, let me just write it properly, delete from our table lists, where ID is equals to ID. So that's the function, and then we're just going to register a callback and say dot then inside here we're going to return a response with a status code of no content, and then we'll handle the error. In case of an error, we say on error and return a response status code http status dot bad request, and duplicate this here. So that means if it doesn't fall here, it will either fall here or here. Now that we have that, let's test it in our terminal. So back here, let's clear all this and run an update request, which is patch. And inside here, we're going to proceed to delete all this. Specify our route to PostgreSQL, and we'll specify the ID as 1, and we'll change our shopping to shopping stuff. So let's enter and see that. True. So let's call in the get. Great. And we'll get to see that in Postico. But for me, let's just see it in Postico before we delete it, right? So back to our Postico. If we try and refresh this, as you can see, it has updated the name. Now let's go back to our terminal and now delete call request delete PostgreSQL and pass in 1. And if we try and run the get, we don't have any list. And if we go back to Postico and refresh this, as you can see, it's empty. So with that, we have been able to not perform CRUD operations in PostgreSQL, which is a relational database. So in this series, the short section where we have been looking at databases alone, we've been able to interact with SQL, NoSQL databases, which is MongoDB and Firestore. And we've also interacted with a relational database as powerful as PostgreSQL. So I hope you have an understanding on how to communicate with databases, where you should be able to create connection instances, and I think we can proceed to the next lesson.